All right, buckle up, everyone, because today we are going on a journey.
To the center of the Earth.
Yeah, you got it. To the center of the Earth. We've gotten so many requests to deep dive into this new research about the Earth's inner core.
And let me tell you, it's a fascinating one.
It really is. We're talking about groundbreaking stuff here, straight from Peking University, published in Nature Geoscience, if you want to look it up. It seems like for ages we all thought the inner core was, just constantly spinning.
Faster than the rest of the planet, yeah.
Right, faster than us up here on the surface. But as it turns out, it's not quite that simple.
It's more of a slow dance.
Right.
And it's got this really surprising rhythm.
A 70-year rhythm. Can you believe that? But before we get too far ahead of ourselves, maybe we should back up for a second. For anyone who's maybe not totally up to speed on all things inner core.
Good point. Yeah, so to really wrap your head around this research, it helps to have a clear picture of what we're dealing with. Imagine the Earth.
As a giant layered sphere. Right.
Exactly. And at the very heart of it, you've got the inner core, this superheated, solid ball of, well, mostly iron and nickel.
Yeah.
Think about 12,220 kilometers in radius.
That's what, like the size of Texas?
Something like that, yeah. And it's sitting way down there, about 5,150 kilometers beneath the surface.
Deep down there. So we've got this solid core, and it's surrounded by
the outer core. And that's a whole different story. It's liquid, molten iron, and nickel. Almost like, a
giant ocean of molten metal.
Yeah, you could think of it that way. And it's this swirling molten ocean that actually creates Earth's magnetic field.
Oh, right. And that magnetic field, that's what protects us from all that nasty solar radiation. Right?
That's basically a shield, deflecting all those harmful particles streaming from the sun. Without it, well, life on Earth would be very different.
Yeah, no kidding. So this new research, it's saying that the inner core, it's not just spinning at a constant speed, it's actually speeding up and slowing down over time.
Right. It's not constantly in that super rotation state that we used to believe. Instead, it fluctuates, going through this cycle of about 70 years.
70 years, that's longer than, well, most people's lifetimes. So how in the world did scientists figure this out? They can't exactly go down there and stick a speedometer on the inner core, right?
No, they can't. They actually use seismic waves to study this. Those vibrations that travel through the Earth after an earthquake?
Oh, right. Okay, so earthquakes happen.
And these waves, they carry information about the materials they pass through. So what these researchers did was they took seismic data from earthquakes going all the way back to the 1960s. And by analyzing how long it took those waves to pass through the inner core, they were able to track changes in its rotation over time.
Wow, that's pretty clever. So basically by listening to the echoes of earthquakes.
They were able to map the movements of the inner core. It's like a giant planetary puzzle.
Yeah, exactly. A really deep puzzle. And what did they find?
Well, one of the big findings was that around 2009, there was a noticeable shift. The inner core's rotation, it basically changed direction.
What? Change direction.
It's almost like it decided to switch up its dance routine. And that's what's got everyone so excited. Because now the question is, well, what does this all mean for us up here on the surface?
Right. Does this deep down dance have any impact on our lives?
That's the million-dollar question. And that's what we're going to start getting into next. Because this inner core's movement, it likely influences the movement of the outer core.
Which, in turn, creates the magnetic field.
Exactly.
So you're saying that the North Magnetic Pole, it's not actually fixed.
Nope, it's on the move. And we'll talk all about that and what it means for us after a quick break.
Sounds good. I'm ready to hear more about this. We'll be right back.
Right after this. So you remember how we were talking about those different theories for what's causing this inner core oscillation?
Yeah, you mentioned something about electromagnetic forces being involved, which sounded pretty wild.
Well, yeah, because we have to remember what's happening in the outer core. I mean, it's this incredibly dynamic layer of molten iron constantly churning and swirling.
Like a giant molten ocean.
Exactly. And as it moves, it generates these electric currents. And those currents, well, they create Earth's magnetic field.
Right, the magnetic field that protects us from solar radiation.
That's the one. And what some scientists are proposing is that these electric currents, they could actually be interacting with the solid inner core.
Wait, so you're saying that the electric currents in the outer core are actually pushing and pulling on the inner core?
That's the idea. It's kind of like, how magnets can attract or repel each other. These electromagnetic forces, they could be influencing the inner core's rotation, causing it to speed up or slow down over time.
So it's like a giant invisible dance between electricity, magnetism, and this solid ball of metal thousands of kilometers beneath our feet.
Yeah, pretty much.
Yeah.
And that's just one theory. There's another idea out there that's even more mind-boggling, well, at least to me.
Okay, lay it on me.
Some researchers think that the inner core itself might have its own internal dynamics.
You mean like movements and stuff? I thought it was just this solid, unchanging ball of iron.
Well, it is solid, but solid doesn't mean static, especially when you're talking about the kind of extreme conditions we find at the center of the Earth.
Right, the immense pressure, the crazy high temperatures.
Exactly.
Yeah.
Under those conditions, well, the iron and nickel atoms in the inner core, they might be behaving in ways that we don't fully understand. They could be creating flows or movements that we haven't even imagined yet.
So it's like, even though the inner core is solid, there's still stuff happening inside of it.
That's the idea. And those internal dynamics, they could be contributing to the 70-year oscillation. It's like trying to solve a puzzle where the pieces are constantly shifting and changing shape.
Okay, my head is officially spinning. But let's get back to the surface for a second. I mean, we talked about the magnetic field, navigation, all that. But are there any other ways that these deep Earth processes might be affecting us up here? I mean, besides just messing with our compasses.
That's a great question. And it's one that's got scientists really buzzing right now. You see, some researchers are starting to explore a potential connection between the inner core and, well, climate change.
Hold on, you're saying that what's going on at the center of the Earth could actually be influencing our climate?
It's a possibility. Remember that chain reaction we talked about earlier?
Mm-hmm.
How the inner core influences the outer core, which then affects the magnetic field?
Right, right.
Well, some scientists are starting to wonder if that chain reaction could go even further, potentially affecting how much solar radiation reaches Earth's atmosphere.
And that could mess with our climate.
Potentially. I mean, think about it. The magnetic field, it acts like a shield, deflecting those charged particles streaming from the sun. But if the magnetic field weakens or becomes more erratic because of the inner core shenanigans...
Did more of those particles get through?
Exactly. And that could lead to more solar radiation reaching Earth. And some scientists believe that increased solar radiation could influence things like cloud formation and even those big atmospheric circulation patterns that drive our weather.
So what you're saying is this little dance the inner core is doing, it could end up affecting our weather patterns, potentially contributing to climate change.
It's a pretty mind-blowing idea, right?
Yep.
And it's still early days in terms of the research. It's a complex connection with a lot of factors at play, but it just shows how interconnected everything on our planet is.
Yeah, no kidding. It's like the Earth is one giant system.
That's exactly right.
Yeah.
And the inner core, well, it's just one part of that system. But as we're learning, it's a pretty important part.
So all this is really interesting, but how do scientists actually study something that's happening thousands of kilometers beneath the Earth's surface? What kind of tools do they have to look that deep?
Well, it's definitely not easy. But scientists are pretty clever. They're coming up with all sorts of ingenious ways to study the Earth's interior. One really fascinating approach is through projects like the International Ocean Discovery Program.
The what?
The International Ocean Discovery Program. It's basically a giant international collaboration that drills deep into the ocean floor.
You're kidding. They're drilling into the ocean floor to study the Earth's core.
Well, not exactly the core itself, but close enough. You see, those core samples they extract from the ocean floor, they're like time capsules.
Time capsules? What do you mean?
I mean, they contain layers of sediment that have built up over millions of years. And those layers, they preserve a record of Earth's history, including changes in the magnetic field. By analyzing those layers, scientists can actually track the movements of the inner core over geological time.
Wow, that's incredible. So they can look back in time and see how the inner core has been behaving for millions of years.
Yep, pretty much. And then there's seismic tomography, which is another really powerful tool. Think of it like taking a giant CT scan of the Earth. By analyzing the way seismic waves travel through the planet.
From earthquakes.
Right, from earthquakes. Scientists can create these incredibly detailed 3D images of the Earth's interior. And those images, they can reveal the structure of the core and mantle, even show us how they've changed over time.
So it's like going from blurry black and white X-rays to full-color, high-definition images of the Earth's insides.
Exactly. And as these technologies continue to improve, who knows what other amazing discoveries await us? We might find that the inner core's dance is even more complex than we thought. Maybe there are subtle variations in its rhythm, or even unexpected patterns that we haven't even considered yet.
So we're just scratching the surface of understanding what's really going on down there.
I think that's a fair assessment. But that's what makes this research so exciting. We're pushing the boundaries of our knowledge, and the more we learn, the more we realize just how much more there is to discover.
So, with all this in mind, Why should the average person care about what's happening deep inside the Earth? I mean, it's fascinating stuff, don't get me wrong, but how does it really affect our lives?
Well, I think it all comes down to understanding our place in the grand scheme of things. This research, it shows us that Earth is this incredibly dynamic, interconnected system. What happens at the core, it can ripple outwards, affecting everything from our compasses to potentially even our climate. It's a reminder that we're all part of something much bigger than ourselves.
And that we still have so much to learn about our own planet.
Absolutely. And who knows what other mysteries are waiting to be uncovered. I mean, if the inner core can influence something as massive as our magnetic field, what other subtle effects might it have on our planet that we haven't even considered yet? It's a question that I think will drive scientific exploration for years to come.
Well, it's certainly given me a lot to think about.
And hopefully it's done the same for our listeners.
For sure. I think it's safe to say that the Earth's inner core is a lot more interesting than we ever gave it credit for.
Uh-huh. Yeah, I think that's a pretty good takeaway from our deep dive today.
I know I keep saying this, but it's just amazing to think about all this stuff happening right under our feet, thousands of kilometers down there.
It is. It really is like our planet has this secret heartbeat.
Yeah, and we're just now starting to figure out its rhythm.
And the more we learn about that rhythm, the more we realize how everything is connected.
Like how the inner core affects the outer core, and then the magnetic field, and then who knows what else.
Exactly. It's a complex system, that's for sure.
Yeah.
And this research on the inner core's oscillations, well, it really highlights that.
It shows that it's not just this hunk of metal down there just sitting still. It's active, it's moving, it's influencing all these other things.
It really makes you appreciate just how dynamic our planet is.
So if we take a step back for a minute, what does all this tell us about the big picture of Earth science? What are some key takeaways that our listeners should really remember from all of this?
Well, I think the biggest takeaway is that we still have so much to learn about our own planet. I mean, we're making new discoveries all the time.
Which is pretty cool when you think about it. I mean, there's always something new to explore.
And that's what makes Earth science so exciting. And I think this research also underscores just how important scientific exploration is. It's through these investigations, these deep dives into the unknown, that we gain insights that can help us deal with the challenges we face as a species.
Like you were saying earlier about how understanding the inner core could help us adapt to a changing climate.
Exactly. I mean, remember how we were talking about the potential connection between the inner core, the magnetic field, and solar radiation?
Yeah, and how changes in the magnetic field could affect how much solar radiation reaches the Earth.
Right. And solar radiation, well, it plays a huge role in climate. So by understanding how all these pieces fit together, we can get a much clearer picture of how our climate system works.
And hopefully figure out ways to mitigate the impacts of climate change.
Exactly. It's not just about understanding Earth for the sake of knowledge. It's about using that knowledge to make informed decisions about our future.
So it's like the more we know about our planet, the better equipped we are to take care of it.
I think that's a great way to put it. Well, we've covered a lot of ground today, literally.
Uh-huh. Yeah, we have. Any final thoughts you want to leave our listeners with?
I just say stay curious. Never stop asking questions about the world around you, whether it's about the Earth, the stars, or anything else that sparks your interest.
Well said. And on that note, I think it's time to wrap up our deep dive into the Earth's inner core. Thanks for joining us on this incredible journey, everyone.
It's been a pleasure exploring this with you.
And until next time, keep looking up, keep looking down, and keep those questions coming.